Okay, so we're still here on page 295. In this case, problem 86. This is in your homework set. This is homework set 20 actually, and this is a sister to problem 88. We've done a couple of problems like this. They're giving us a function, in this case an exponential function, asking us to find some information about it, then calculate its inverse and find some similar information. So let's proceed as we have in the past here. Let's try to graph f of x by using transformations, starting then with the kind of basic function f of x equals e to the x. I think you know that that looks a little bit like this, where this is the 0, 1, because after all, e to the 0 is equal to 1, and this is y is equal to e to the x. If we want to take the next step and stretch that graph, then the function y equals 3 to the x is this function with every point raised up by a factor of 3. So this point 0, 1 will become the point 0, 3, and this then we're going to call y equals 3 e to the x. And then 2 has a similar effect. This additional 2 has an additional effect. It will raise everything up by 2. So this is not a multiplicative increase. This is an additive increase. I'm going to come down here. I'm going to draw the line y is equal to 2, and then we're going to just draw this function y equals f of x is equal to 3 e to the x plus 2. And if this point right here was 0, 3, then this point is going to be 0, 5. And there you have it. So very quickly, what's the domain of f? It's all x. There's the graph. What is the range of f? It is all y greater than, not greater than or equal to, but greater than 5. E to the x is asymptotic to the x-axis. Therefore, y equals 3 to the x is asymptotic to the x-axis as well. And f of x equals 3 e to the x plus 2 is asymptotic to this horizontal asymptote y is equal to 2. I said 5. This is greater than 2. Okay? And there's the asymptote y is equal to 2. So next step, let's go and find the inverse to f. This now is a pretty familiar procedure to you. Let's change out x for f to the minus 1, e to the f to the minus 1 plus 2. We know that this value then is equal to x, since f and f to the minus 1 are inverses. They undo one another. Start with an argument of x, run it through f to the minus 1, run it through f, you'll get x right back. So to solve this, I'm going to say 3 e to the f to the minus 1 is equal to x minus 2. That means e f to the minus 1 is equal to x minus 2 divided by 3. And now if I essentially take the log of both sides, then f to the minus 1 of x is equal to the natural log of x to the minus 2 all over 3. All right, and if we're asked then to plot that function, and I think we are, I'm going to come up here and draw the line y is equal to x, and then we're just going to form a reflection around that line in this manner. Right? And there is a vertical asymptote here. This horizontal asymptote on f turns into a similar vertical asymptote on its inverse. So that is the line x is equal to 2. So given that, this is the inverse function. F to the minus 1 of x is equal to the natural log of x minus 2 all over 3. And so we can finish out answering the questions here. Natural log x minus 2 all over 3. What's the domain? It's everything greater, all values of x greater than 2. Yep. What's the range? It's everybody from infinity to minus infinity to infinity. And just as a double check, we see that the domain of f is the same as the range of f to the minus 1, both being minus infinity to infinity. And the domain of f to the minus 1 is the range of f, both being x or y greater than 2. Okay, I think we're done with page 95, and none too soon. Those are demanding problems.